We're going to look at isotope problem number 1A in your lecture outline. And this problem asks to calculate the number of protons, neutrons, and electrons in a nitrogen 14 atom that has a -3 charge. This -3 charge indicates that nitrogen has gained 3 electrons. And since it has gained 3 electrons, now it becomes nitride, so it's going to have a -3 charge. And if you look at our symbol here, nitrogen 14, it has a mass number of 14, so that would be the superscript. And according to the periodic table, it has an atomic number of 7. And we're putting our symbols on the left-hand side because the charge is indicated here. And now let's go ahead and draw a table to show our number of protons, neutrons, and electrons. Our number of protons is 7 from the periodic table. Since it has gained 3 electrons, we take 7 plus 3, and now it will have 10 electrons because it has a -3 charge. And to determine the number of neutrons, that will be the mass number minus the number of protons. And that will be 14 minus 7 protons. 14 is protons plus neutrons. So therefore we have 7 neutrons in our nitride atom. So the final answer in this problem is that it has 7 protons, 7 neutrons, and 10 electrons. Now the next question, it's related to the first question, and it asks to calculate the total number of subatomic particles in this ion. And we can nickname subatomic particles SAPs. And SAPs is going to equal the number of protons plus the number of neutrons plus the number of electrons. And we have all this information from up above. So we have 7 protons plus 7 neutrons plus 10 electrons, and that will equal a total of 24 SAPs that are in our nitride atom. Looking at problem 2, we want to determine an isotope of copper that has 3 more neutrons than copper 63. And we know that the 63 represents the mass number. So if we were going to go ahead and write the symbol for copper 63, it would be copper has a mass number of 63, and the atomic number is 29, which we obtained from the periodic table. So drawing a table, this is what we have. We have 29 protons, 34 neutrons, and 29 electrons. And what we need to do is it's asking us to add 3 more neutrons. So let's go ahead and add 3 more neutrons, and that will mainly affect the mass number. Okay, if we look and we add 3 more neutrons, so right now we have 34 neutrons plus 3 neutrons, so now we have 37 neutrons in our new isotope of copper. Remember that the atomic number never changes, so that's always going to be copper 29. Since the number of neutrons is changing, we need to find the new mass number. So the mass number will equal the number of protons plus number of neutrons. So in this case, number of protons is 29, and the number of neutrons is 37 in our new isotope, which gives us 66. So our new mass number is 66. So the final answer indicated for the new isotope of copper is copper 66 with the atomic number 29. Let's go on to number 3. We're looking at chromium, which has the same number of electrons, protons, and neutrons. So let's go ahead and just look at chromium and draw a table for the number of protons, neutrons, and electrons. According to the periodic table, it has an atomic number of 24. Since it's a neutral element, just chromium itself, it's going to have 24 electrons. And if we subtract the mass number minus the number of protons, we end up with 28 neutrons. And let's go ahead and draw a new table for the isotope of chromium that has the same number of protons, neutrons, and electrons. The protons will always remain the same. It's like the atomic DNA. Because it's neutral, the electrons will also remain the same. So what we need to change here is the number of neutrons and keep it so it's the same as the number of protons and electrons. So we're going to write this as 24. So let's go ahead and write our isotope for chromium. The total number of protons and neutrons is 48. So the mass number is 48. And now the number of protons is 24. The answer to number 3 is chromium 48 with an atomic number of 24. In our next problem, we are looking for an atom with 5 more neutrons and 2 more protons than phosphorus 31. Since we're changing the number of protons, we're going to have a new nucleus, meaning it's no longer going to be phosphorus because we're changing the identity of our atom. If we go ahead and look at phosphorus 31 and draw a table for the number of protons, neutrons, and electrons, it has 15 protons, 15 electrons, and 16 neutrons. And what the problem is asking is we want to add 5 neutrons and add 2 more protons. So I'm going to go ahead and draw an arrow here for the new table. So what we're doing is we're going to add the number of protons. So now 15 plus 2 is 17 protons. And now we're going to add 5 more neutrons, so that ends up being 21 neutrons. Since this is a neutral element that has no charge, it's going to have 17 electrons. And we can go turn to the periodic table to identify what our new nucleus is. And if you go to the periodic table, it's chlorine that has an atomic number of 17. And if we add 17 protons plus 21 neutrons, our mass number is now 38. In problem 5, we are to find an isotope of sulfur that contains the same number of neutrons as silicon, 28. Let's go ahead and draw a table for silicon 28. Remember, if we go to the periodic table, it has atomic number of 14. And number of protons for silicon is 14. Number of electrons is also 14. And if we take 28 minus 14, it's going to have 14 neutrons. And what we need to find is what this isotope of sulfur is. So let's go ahead and draw another table that will give us the number of subatomic particles in sulfur. And sulfur has an atomic number of 16 in the periodic table. Since it's neutral, it also has 16 electrons. And according to the problem, we want the same number of neutrons. So we need to keep 14 the same. So this is going to have 14 neutrons. We can find our mass number by taking the number of protons plus the number of neutrons. So 16 plus 14 gives us a mass number of 30. And the number of protons is 16. So our isotope of sulfur is sulfur 30 with an atomic number of 16. That's our answer. Okay, on our last problem on isotopes, we are looking for an isotope of iron that contains the same number of saps as nickel 59. So let's go ahead and draw our symbol for nickel 59 that has an atomic number of 28 and indicate the number of protons, neutrons, and electrons in our table. It has 28 protons according to the periodic table. The number of neutrons is 31, and the number of electrons is also 28. And to find the total number of saps, we're going to add the total number of protons, neutrons, and electrons, which gives us a total of 87 saps. And we need to make sure that our nucleus of iron contains that same number of saps. So we're going to go ahead and draw another table for iron. Remember that the atomic number never changes, so we're going to leave it at 26 protons. And as well as the number of electrons, it never changes unless it has a charge. So it's 26 electrons. Now we need to make sure it has the same number of saps, so we're going to take 87 saps minus 26 protons minus 26 electrons, which gives us a total of 35 neutrons. Okay, so if we add the number of protons plus neutrons, it's iron 61, and the atomic number is 26. So this is your answer for number 6. It's iron 61 with an atomic number of 26.